In this video, we're going to talk about how to find the antiderivative of a function. So what is the antiderivative? Well, as the name implies, it is the opposite of differentiation. We know the derivative of f of x is f prime of x. So the antiderivative, or the integral of f prime of x, is f of x. So f of x is the antiderivative of f prime of x, whereas f prime of x is the derivative of f of x. Now the integral, or the antiderivative of regular f of x, is capital F of x. So capital F is the antiderivative of lowercase f, and lowercase f is the antiderivative of f prime of x. So hopefully that gives you a good idea of what the antiderivative is. So let's say if we have the second derivative of a function and we want to find the first derivative, and we can keep going forward in this direction. I just want to give you an overview of these different symbols and functions. So going to the right, we're looking for the antiderivative. Going to the left, we're looking for the derivative. The process of finding the antiderivative is basically integration. The process of finding the derivative is differentiation. So hopefully that summarizes everything that you need to know about this conceptually. Now we said that capital F is the integral of f of x dx. Now you get capital F plus c. You always get a constant of integration, but we're not going to worry about that here. What I'd like to do right now is distinguish what is an indefinite integral versus a definite integral. So this here is what is known as an indefinite integral. An indefinite integral gives you a function, typically in terms of x, but it could be in terms of some other variable like y or z or something like that. A definite integral doesn't give you a function, but it gives you a number. So this is a definite integral. The result of a definite integral is always a number like 20, -8, 45, or something. And you can easily identify or distinguish a definite integral from an indefinite integral. A definite integral has limits of integration. It has a lower limit and an upper limit. An indefinite integral does not have the limits of integration. So that's how you can easily distinguish between them. Now we know that the derivative of x cubed is 3x squared. According to the power rule, the derivative of a variable raised to a constant is the constant times the variable raised to the constant minus 1. Well, the antiderivative of a variable raised to a constant is going to be that variable raised to the constant plus 1 divided by the constant plus 1, and then plus c, the constant of integration. So that's how we could find the antiderivative of a variable raised to a constant. So let's find the antiderivative of 3x squared. So let's rewrite the constant. Now the variable raised to the constant, that's x squared. So what we're going to do is we're going to add 1 to the exponent. So it's going to be 2 plus 1, and then we're going to divide by that result. So it becomes 3x cubed divided by 3. And this gives us the original function x cubed. But we need to add the constant of integration plus c. If you were to find the derivative of x cubed plus c, x cubed will become 3x squared. The derivative of a constant will become 0. So you end up with the same thing. So always, when you're looking for the indefinite integral of something or the antiderivative, you need to put the constant of integration. The only time you don't need to worry about the constant of integration is if you're finding the definite integral, where you get a number. Besides that, anytime you get a function, add plus c when you're looking for the indefinite integral or the antiderivative. So now let's work on some problems. Go ahead and find the antiderivative of the following functions. Feel free to pause the video and work on these examples. So for the first one, we're just going to add 1 to the exponent. 4 plus 1 is 5. And then we're going to divide by the result and then add the constant of integration. So it's x to the 5th power over 5 plus c. For the next one, it's going to be x to the 8 over 8 plus c. For the next one, it's going to be 6. And then we're going to add 1 to 9. That becomes 10. Divide by 10 plus c. Now this one we can reduce. 6 over 10, if we divide both numbers by 2, that becomes 3 over 5. So we could say this equals 3 over 5 x to the 10 plus c. For the next one, it's going to be 8 x to the 4 over 4 plus c. And we know 8 divided by 4 is 2. So this is 2 x to the 4 plus c. So as you can see, it's not that difficult to find the antiderivative of a function. So go ahead and try this one. Find the antiderivative of, so let's write it this way. Let's say f of x is x cubed minus 4x squared plus 8x. What is the antiderivative, capital F of x, of that function? So go ahead and find the antiderivative f of x. To do that, we're going to find the indefinite integral of x cubed minus 4x squared plus 8x. But just to show our work, let's do it this way first. So the antiderivative is going to be the indefinite integral of f of x dx. So that's the formula. And now let's replace f of x with x cubed minus 4x squared plus 8x dx. So the antiderivative of x cubed is going to be x to the 4 over 4. And then for 4x squared, it's going to be 4x cubed over 3. And then for 8x, it's 8x squared over 2 plus c. Now let's rewrite it. So we're going to rewrite it as 1/4 x to the 4 minus 4 over 3 x cubed. And then 8 over 2 is 4. So we'll write that as 4x squared plus c. So this is the antiderivative of the original function. Now let's try another problem. So let's say f prime of x, that is the first derivative of x, the first derivative of f rather, let's say that's equal to 8x cubed minus 6x squared plus 4x minus 7. So given f prime of x, find the antiderivative f of x. Go ahead and try that. So first, let's write an expression involving indefinite integrals. So we could say that f of x is the indefinite integral of f prime of x dx. So f of x is the antiderivative of f prime of x. So f of x is going to be the indefinite integral of 8x cubed minus 6x squared plus 4x minus 7. Feel free to pause the video if you want to try this. So the antiderivative of x cubed is x to the 4th over 4. For x squared, it's x cubed over 3. And for x to the first power, it's x squared over 2. And then if you have a constant like 7, all you got to do is add an x to it. We'll talk more about that shortly. And then finally, plus c. So now let's simplify our answer. So the antiderivative is going to be 8 divided by 4 is 2, so we have 2x to the 4th power. 6 divided by 3 is also 2. 4 divided by 2 is the same. So this is the antiderivative of our original function. 2x to the 4th power minus 2x cubed plus 2x squared minus 7x plus c. So as you can see, it's not too difficult to find the antiderivative, but there are other things that you need to know. Go ahead and find the indefinite integral of these expressions. Let's make this a z. All right, so go ahead and try those. So let's start with the first one. We want to find the indefinite integral of a constant, 5. And we have dx in front of it. So we know it's going to be 5x. But let's see if we can get the answer using the power rule. 5 is the same as 5 x to the 0. Any variable raised to the 0 power is 1. So x to the 0 is 1 times 5, which is equivalent to 5. Now, using the power rule, this is going to be 5. We're going to add 1 to the exponent and then divide by that result. So the end result is that you get 5x plus c. So whenever you have a constant and you wish to integrate that constant, just add a variable to it. Now the variable that you should add is based on what you see here, either dx, dy, dr, or dz. So what is the indefinite integral of 7 dy? So instead of 7x, this is going to be 7 times y plus c. So the differential, dx, dy, it tells us what variable we should be adding to the constants. The indefinite integral of 8 dr, that's going to be 8 times r plus c. For 6z plus 4, it's going to be 6, and then z to the first power, that becomes z squared over 2. 4 becomes 4z, and then we'll add plus c. So this we could simplify it as 3z squared plus 4z plus c. So that is the indefinite integral of 6z plus 4. Try this problem. So let's say you're given the first derivative of f. And let's say it's 7. This should be not f of x, but f prime of y. So let's say it's 7y cubed minus 3y plus 8. And your goal is to find capital f of y. How would you do it? Feel free to pause the video and try it. So first, let's write a mental outline of what we need to do here. We're given the first derivative of f. we need to find f. So f is the antiderivative of f prime, but we're not going to stop there. We need to find capital F. So what we need to do is we need to integrate the function 2 times. So we have a successive integration problem. So first, let's integrate it the first time. Let's find regular f, or little f. So this is going to be the indefinite integral of f prime of y dy. So that is the indefinite integral of 7y cubed minus 3y plus 8. So the antiderivative of y to the third is going to be y to the fourth over 4. The antiderivative of y is y squared over 2. And for the constant 8, it's just going to be 8y based on what we have here, dy. And then plus the constant c. So that's f of y. We don't know what the value of c is. If we were given a point of f of y, we could find c, but we'll save that for another problem. So this here is the general function of f of y. So now let's find capital F of y. That's going to be the indefinite integral of f of y dy. So that is the indefinite integral of 7 over 4 y to the fourth minus 3 over 2 y squared plus 8y plus c as well. And we're going to have dy. So the antiderivative of this, we're going to rewrite the constant, and then we'll find the antiderivative of y to the fourth. So that's going to be y to the fifth over 5, and then minus. Let's rewrite the constant first. So we have 3 over 2, and then the antiderivative of y squared is going to be y to the third over 3. And then it's going to be plus 8 times y squared over 2. Now we have the constant of integration c. So we're going to add a y to it. It's going to be c times y, and then plus a new constant, which we'll call d. So this becomes 7 over 20 y to the fifth. Here we can cancel the 3's. So it's going to be minus 1/2 y to the third plus 4 y squared plus cy plus d. So that is the second antiderivative of f prime of y, which is capital F of y. By the way, for those of you who want access to the full-length version of this video, check out the links in the description section below. If you join my YouTube channel membership program, you can get access not only to the full-length version of this video, but many other full-length versions of other videos that I have on YouTube, which you'll see over time. So feel free to take a look at that when you get a chance. Now let's work on finding the indefinite integral of other types of functions. What is the indefinite integral of pi d theta? Feel free to pause the video and work on that. And what is the indefinite integral of e, let's say e ds? So pi is a constant. Let's compare it to the indefinite integral of 7 dy. 7 is a constant, and we would add the variable y to it, so this will be 7y plus c. So pi is a constant, and here we're going to add the variable theta to it, plus c. So that's the indefinite integral of pi d theta. So remember, pi is a constant. It's 3.14 with some other numbers after that. Let me find out what those other numbers are. So it's 3.141592654 with some other numbers. So whenever you see pi, it's just a constant. So treat it as if it's any other number like 7 or 8 or -4. The same is true for e. E is not a variable, it's a constant. E is equal to 2.71828 and so forth. So when looking at a problem like this, E is the constant, S is the variable. So this is going to be E times S plus C. Whenever you're finding the indefinite integral of something, you need to be able to distinguish the constant from the variable in order to integrate it properly. Now let's focus on finding the indefinite integral of rational functions. What is the indefinite integral of 1 over x squared? To find this, before you integrate it, you need to rewrite the expression. We need to move the variable from the bottom to the top. So this is x to the -2. At this point, we could use the power rule. So we can integrate it by adding 1 to the exponent. So it's going to be -2 plus 1, and then dividing by that result, plus c. -2 plus 1, that's -1. And after you integrate it, you need to rewrite it again. So we want to get rid of this negative exponent. And we can do so by moving the variable back to the bottom. So that leaves a 1 on top. And then we're going to have x to the first power on the bottom, which we can just leave as x. The negative sign, I'm going to move it to the top. So the final answer is -1 over x plus c. Now let's try this one. What is the indefinite integral of 1 over x to the 5th power, dx? So feel free to pause the video and try it. So just like before, let's move the variable to the top. So we have the integral of x raised to the -5 dx. And then let's add 1 to that. So -5 plus 1 is -4. And then we're going to divide by that result. Next, let's rewrite the expression. So we're going to move the variable back to the bottom, and the negative sign, we're going to move it to the top. So we're going to have -1. We have a 4 on the bottom, and x, and then this -4 becomes +4, plus c. So -1 over 4x to the 4th plus c. That is the indefinite integral of 1 over x to the 5th power. Try this. Find the indefinite integral of 7 over x cubed dx. So like before, we're going to move the variable to the top. So we're going to rewrite the integral. So this is 7x to the -3 dx. And now let's integrate. So -3 plus 1, that's -2. And then we're going to divide by -2, and then we'll have plus c. So next, we're going to move the variable back to the bottom, and the negative sign I'm going to move to the top. So this becomes -7. We have a 2 on the bottom, and we have x squared as well. So it's -7 over 2x squared plus c. So that's how you can integrate rational functions. Go ahead and try this expression. Find the indefinite integral of 5 x to the 7 minus 9 over x squared plus 4x minus 8 dx. So this is going to be 5 x to the 8 over 8. Now for -9x squared, we need to write that as -9x to the -2. So that's going to be -9x, -2 plus 1 is -1, divided by -1. And then for 4x to the first power, that will be 4x squared over 2, and then minus 8x plus c. So we can rewrite this as 5 over 8 x to the 8 plus 9. The two negative signs will cancel, and then we can move the x variable to the bottom. So it's plus, it's plus 9 over x, and then plus 2x squared minus 8x plus c. So that is the indefinite integral, or the antiderivative, of this expression. Now, what is the antiderivative of 1 over x dx? What do you think we need to do here? Well, if we were to try the same approach that we've been using for rational functions, let's say if we were to rewrite the expression by moving x to the top, we would get the indefinite integral of x to the negative 1 dx. Now, using the power rule, if we add 1 to negative 1, we'll get x to the 0. And if we were to divide by that result, we would get something that is undefined. So this technique doesn't work for 1 over x. Instead, this is an integral that you should commit to memory. The integral of 1 over x dx is simply ln x. So you may want to add that to your list of notes. And if you recall, the derivative of ln u, where u is a function of x, is u prime over u. So the derivative of ln x is going to be u prime. If u is x, u prime, the derivative of x is 1. So we get 1 over x. So that's the antiderivative of 1 over x to the first power. So if the antiderivative of 1 over x is ln x, what is the antiderivative of 1 over x plus 3? This is simply the natural log of x plus 3. So based on that, go ahead and find the antiderivative of the following expressions. 1 over x minus 5 dx, 5 over x plus 2 dx, and 7 over x plus 4 dx. So this is going to be the natural log of x minus 5 plus c. Now typically, if your answer is like different than ln x, normally you'll see an absolute value around x minus 5. And the reason for this is that you can have a negative number inside the natural log. It's going to be like, it's going to give you an error in the calculator. So typically you'll see an absolute value symbol for expressions that can be negative. For the next one, let's move the constant to the front. So think of this as 5 times the integral of 1 over x plus 2 dx. So this is going to be 5 times the natural log. And let's put our absolute value symbol. So it's 5 ln x plus 2 plus the constant of integration. For the next one, let's do the same thing. Let's move the constant to the front. So this is going to be 7 natural log x plus 4 and then plus c. So that's how you can integrate rational functions where the denominator is a linear function, like x plus 2, x minus 5, and so forth. Now, here's a general formula that you can use when integrating rational functions like 1 over u, where u is a function of x. It's going to be 1 over u prime times the natural log of u plus c. Now, this works if, and this is a big if u is a linear function in the form ax plus b. Now, a could be 0, b could be 0. Well, if a is 0, it doesn't work, but b could be 0. But u has to be a linear function in that form. If there's like an x squared or an x cubed, this formula is not going to work. So let me repeat that. U has to be a linear function. If you have a square root of x or anything but x to the first power, this will not work. So now let's try some harder examples. Based on that, what is the indefinite integral of 1 over 3x plus 4? And let's compare that to the indefinite integral of 1 over x plus 7. So in this case, we can see that u is 3x plus 4. The derivative of u, which is u prime, the derivative of 3x is 3. The derivative of 4 is just nothing. So u prime is 3. So this becomes 1 over 3 ln absolute value 3x plus 4. And then plus c. So this fraction is a result of the derivative of that expression. For the next one, the derivative of x plus 7 is just 1. Here, the derivative of 3x plus 4 is 3. So that's why you got to incorporate that. So for the next one, u is going to be x plus 7, and u prime is just going to be 1. So this becomes ln absolute value x plus 7 plus c. So knowing that, go ahead and try these two. Oh, by the way, let's go back to what we had before. Let's prove that this is indeed the right answer. So let's find the derivative of 1/3 times ln 3x plus 4. So this is going to be 1 over 3. And keep in mind the derivative of ln x, or ln u rather, is u prime over u. So the u part is what is inside of the natural log function, and so that's 3x plus 4. U prime, the derivative of 3x plus 4, is just 3. And the derivative of c is 0. And so when we cancel the 3's, we're going to start with our original function, which is what we had here. So that shows you that the process works.